Good morning, students. So today our topic is arithmetic progression. Okay, let us start. Here we can see a ladder, and these are known as rungs of the ladders. Everyone know it? Okay. So what we can see that these rungs are decreases when goes from down to top. Okay, and what if we take the length of this last rung as 60 centimeter, and we can then the next one 50 as a 57 centimeter, and this one is 54, 51, 48, 45 and 42. So student, here we get an pattern. Here we get an pattern after subtracting a fixed number 3 from each term. Okay, and that term is 3. That fixed number is 3. Like 60 minus 3 is 57. 57 minus 3 is 54 and so on. Okay. So now we see the following list of number. Here the first series is given 1, 2, 3, 4, 5, and we have to calculate the next term. So how we can calculate? So see here, if we add in the first term 1, we will get 2, which is the second term. Okay, and if we'll add in second term 1, we will get the 3, which is the third term of this series. And similarly, if we can add 1 to 5, we will get 6, which is our next term. Okay, similarly in this we had 400, we have given series is 400, 350, 300, 250, 200, 150, and we have to calculate the next term. Then we can see from here that the difference is of 50. Okay, and here is also the difference of 50. Here 50, here 50, here 50. So what is the difference in next term? Also 50. So 150 minus 50 is equal to 100. So this is our next term. Okay, now see, so from this pattern we will easily calculate this next term of this series. Okay, so here we get the 2 and here we get the 0, because here is the differences of 0. Okay, now from this, so now we can say that what is an AP? That AP is the list of numbers in which each term is obtained by adding a fixed number, and we can say this fixed number as D, or we can say it a common difference. Okay, also let us given a series 21, 23, 25, 27 and so on up to 43. So what we can see here that the last term of this series is given. So this type of series is known as finite arithmetic progression. Okay, and if the last term of an AP is not given, then that AP is known as infinite AP. Okay, next we will learn about some things of an AP. So let us take this 200, 150, 100, 50 and so on up to infinite. Okay, so here the first term is known as A1. We are denoted first term as A1, the second term as A2, the third term as A3 and the fourth term as A4. Let us take the nth term as AN plus R. Okay, where AN plus R is the nth term of the AP. And we also know that we take D as we can take D as a common difference. Okay, or we can say it a fixed number. Here noted that this D may be positive, negative and 0, as we see it earlier from here. It can be positive, it can be negative, it can be 0. Okay. Now let us learn about general term of an AP. What is general term of an AP? The general term of an AP is given by an is equal to a plus n minus 1 into d, where this an is the nth term of an AP and a is the first term. Here d is the common difference and n is the total number of the AP. From the definition of the common difference, we can also denote d as an plus 1 minus an. Okay. For example, if the three terms 6, 4, 2 are in the AP, then from here 4 minus 6 and 2 minus 4 become equal. Common difference is same, is a fixed, so it will be minus 2. Or we can also say if the three terms A, B, C are in AP, so we can write B minus A is equal to C minus B, or if we add it here, then we will get 2B is equal to A plus C. Now we take some examples. Here in the first example, we have to calculate first 4 terms of the AP. So here, see, first term is given, which is 10, and D, which is a common difference, it is also given 10. So first term is denoted by A1. So A1 is equal to 10. And how we will calculate the second term? By adding the fixed number into the first term. So here see, A2 is equal to A1 plus D, which is equal to 10 plus 10 is equal to 20, which is our second term of the AP. Similarly, the third term, how we can calculate it? A3 is equal to A2 plus D, which is equal to 20 plus 10 is equal to 30. And A4 is equal to A3 plus D, which is equal to 30 plus 10 is equal to 40. So, thus, the first 4 terms of the AP are 10, 20, 30 and 40. Similarly, we can take another example where A is equal to 4 and D is equal to minus 3. Here we can take the common difference is negative, which is minus 3. So first term is 4. We can denote it by A1. And the second term A2 is given by A1 plus D, which is 4 plus minus 3 is equal to 1. A3 is equal to A2 plus D, 1 plus minus 3 is equal to minus 2. And the fourth term A4 is equal to A3 plus D is equal to minus 2 plus minus 3, which is equal to minus 5. Okay. So the first 4 terms are 4, 1, minus 2 and minus 5. Now take another example in which we have to find out the nth term of the following AP. Okay. How we can calculate the nth term? By the formula an is equal to a plus n minus 1 into d. So in this example, we have given a is equal to 7, which is the first term, common difference is 3 and total number of terms given are 8. So put these values in our formula of the general term and nth term of the AP to calculate, which is equal to 7 plus 8 minus 1 is equal to 3, which is equal to 7 plus 7 into 3, and we will get the nth term an. N term means last term of the AP, which is 28. Okay, so we will get the AP. Okay, and this AP is given by 7, 10, 13, 16, 19, 22, 25 and 28. Last term is 28 and total number of terms become how many total terms? 8. Okay, so we can similarly take another example where a is equal to minus 18, common difference is 2, total number of terms and 10. We have to calculate the nth term of the AP. So by putting these values in the nth term formula, we can find out the nth term. So here we can obtain the nth term of the AP, which is equal to 0, and the AP is given by like this. Okay. Now we can take an example which is little different from these. Here we have to find the 20 term. We have to find the 20 term from the last term of the AP. And AP is 3, 8, 13 and so on up to 253. Here we see that the first term is 3 and the last term is 253. And we have to calculate the 20 term from the last term. it means we have to calculate 20 term from the last term. Yani if we can take this last term as the first, then what will be the 20 term? Okay, so here in this given AP, first term is 3 and common difference 8 minus 3, that is 5, and the first term from the last is 253, then the difference is minus 3. Okay, you can easily calculate. So we have to calculate A20 is equal to A plus n minus 1 into D, total number of terms 20 minus 1 into D. So first term from the last is 253 plus 19 and the common difference is minus 5. So we will get the 20 term from the last, which is 158. Okay, so now we will study what is the sum of the first n terms of an AP. How we will calculate sum of the first n terms of an AP. So see here a AP is given, which is 2, 7, 12 and so on up to 10 terms, and we have to calculate the sum of these 10 terms. So here the first term is 2, the common difference is 5, 7 minus 2, 5, okay, and total number of terms are 10. We have to calculate sum of these 10 terms. So we can calculate it easily by the formula. See, we all know about the n term formula, which is A plus n minus 1 into D. So we can add first term to it and multiply whole by n by 2. Okay, so here we get n by 2 into 2a plus n minus 1 into D. Okay, so put these values here. 10 by 2, n is equal to 10. 10 by 2, first term is 2 plus 10 minus 1 into 5, which is equal to 5 into 4 plus 9 into 5, and we will get 245. This is the sum of our first 10 terms. Now see, we know Sn is given by n by 2 a plus n minus 1 into D. Here this a plus n minus 1 into D is what? An, which is given by a plus n minus 1 into D and is known as the last term of the AP. If we can denote this an by L, then what we will get? Sn is equal to n by 2 a plus L, n by 2 into a plus L, means sum of the n terms is n by 2 multiplied by first term plus last term. Note that in the case of infinite AP series, where the number of terms in an AP is infinite means unlimited, then it doesn't have a last term. Okay, so now we can see some examples. Find the sum of the following APs. So given AP is 0.6, 1.7, 2.8 and so on up to 100 terms. So here A is 0.6, first term is 0.6, common difference D, which we can calculate. 1.7 minus 0.6 is 1.1 and total number of terms are 100. So we can easily calculate the sum of 100 terms, which is given by n by 2, 2a plus n minus 1 into D. So put the values as 100 is equal to 100 by 2, 2 into 0.6 plus 99 into 1.1. We will get 50, 1.2 plus 108.9, and which is equal to 50 into 110.1, and sum of the 100 terms is equal to 5505. Similarly, we can solve this example also, in which the series is given minus 37, minus 33, minus 29, so on up to 12 terms. Okay. So now we take another example where we have to find the sum if the last term of the AP is given. Here see, in this AP the last term is given but the total number of terms are not given. So first we have to calculate the total number of terms. Okay, so here first term is 7 and the common difference we can calculate 10 and a half minus 7, which is equal to 7 by 2, and the last term, which is an, is noted by 84. Okay, so we know that an is equal to a plus n minus 1 into D. Put the values. 84 is equal to 7 plus n minus 1 into 7 by 2. Okay, so from here after calculating we will get the number of terms. So here we get the total number of terms in the given AP series are 23. So now we can easily calculate the sum of the 23 terms if we know the last term of the AP. So Sn is equal to n by 2. A plus L means first term plus last term. So S23 is equal to 23 by 2 into 7 plus 84, which is equal to 23 by 2 into 91 and is equal to 2093 by 2, or we can also write it as 1046.5. Okay, so that's all for today.